In Heads Rail, there are 3 methods to design railway yard: 1. Workspace method of interactive design, 2. Project data file method for batch processing, and 3. Text data files method, old classic method. Method 1, Workspace method of interactive design 4.4, railway yard design. This method starts with one single file, which is the total station topographic survey data file, and creates various reports, models, drawings, etc., and finally creates the project data file, which is the backup of all design data. Once the design is completed, the whole process will be available in folder Work 2, after closing Heads Rail at the end of the current session. Next time, to open the project, user may double-click the project tag design job number 1.hrl inside folder as Work 2 Railway Yard Design. To process data in workspace mode, Method 1, user may have the total station survey data file survey.txt in any folder. User may select this file to process the design by following the steps described stepwise in this session. Step 1. Open main screen of Heads Rail. By double-clicking on the desktop icon, select menu item file, select working folder. Step 2. The folder is selected as exists, or user may browse and create and select a working folder. Step 3. Select menu item, file new/open project workspace railway design suit new/open railway yard design. Step 4. Project workspace opens for railway yard design. Click on button open tutorial example data. The example data is loaded tutorial railway yard design inside user's working folder. Step 5. The message comes confirming that example data is loaded successfully. Click on button OK to close it. Step 6. The total station survey data file is opened in Notepad, after viewing close Notepad. Step 7. Open tab window process survey data. In this tab there are 3 more tabs. The first tab is opened as Step 1, ground model. Click on button create ground model. Step 8. As the process is over, the message comes. Click on OK. Step 9. The list of survey features comes. Click on the color box for feature PO. Step 10. Select a desired color. Click on button apply. Step 11. Click on button draw at the bottom of the list of all features. Step 12. The ground model is drawn with all the selected features. Step 13. Open tab window. Step 2. Triangulation under primary tab process survey data. Click on button create triangulation model. The process dialog box come. Click on button proceed. Step 14. As the process is over, the message comes mentioning about the output. Click on button OK. Step 15. Open tab window. Step 3. Contour under primary tab process survey data. By default the primary contour interval is shown as 1.0 m. The secondary contour interval is always 5 times of the primary interval. In case of a flat ground, the primary contour interval may be given as 0.1 mm and the secondary interval will be 0.5 m. The contour elevations will be written on secondary contours. Click on button create contour model. Step 16. The process dialog box comes. Click on button run. Step 17. The contour window opens and shows the process of creating contours on the triangulation model. Step 18. As the process is over, click on the button save on top panel of the contour window. Step 19. Next, click on yellow color contour icon at the bottom panel of the contour window. As the dialog box comes, click on the button quit to close the contour window. Step 20. Next, we are back to the tab for contour in the project workspace. Click on button draw contour model. Contours are being drawn and wait for some time. Step 21. The contour model is drawn over the ground model. Step 22. Next, open the tab page Railway Yard Design. It contains tab pages from Step 4 to Step 9 under this tab page for Railway Yard Design. The tab page Step 4 to process Heylin design data is currently open, for the design of horizontal alignment of center lines of 21 railway tracks to accommodate the trains Indiana the Yard. Step 23. The batch process window comes with the list of Heylin data for 21 track center lines. The data are taken from Heylin design report of all the track center lines, as described in last chapter. Click on button proceed. Step 24. As each process comes, click on button proceed. Step 25. As process is over, the message comes informing about the design report. Click on OK to close it. Click on finish to quit the process. This process will appear 21 times for center line strings M001 to M021 for 21 tracks in this example where the tracks are entering the railway yard. The above actions are to be repeated each time. Step 26. Click on button finish to close the window, which completed the process of 21 Heylin data in the list. Step 27, next, click on button View Halon Design. Step 28, the pop-up dialog box comes with list of all the strings from M001 to M021, click on button Draw Strings. Step 29, the strings are drawn in the CAD window of the project workspace, this is just for viewing only. Step 30, click on button Shenage On, the dialog box comes, select the string M001 and enter other details, click on OK. Step 31, the shenages are displayed along the alignment of the track center line string M001. Step 32, next, click on button Details On. Step 33, the dialog box comes, select a string say, M001, select a string say M001 and enter other details, click on OK. Step 34, the details of horizontal intersection points, hips, and curves, are displayed along the center line string M001. Step 35, next, open the tab page. Step 5 for the design of vertical profile of the railway yard, click on button Create Ground Long Section to create 21 strings as E001 to E021 by following the alignments of M001 to M021 and picking up ground elevation from the digital terrain model which was already created by triangulation. As the process starts, the process box comes with a list of all the 21 processes. Step 36, click on button Proceed. As the process starts, the process dialog box comes. Step 37, click on button Proceed, the ground elevations are picked up by following the alignment of string M001. Step 38, the ground long section string as E001 is to be created in the model files, the message comes informing about the same, click on OK to close it. Step 39, the ground long section string is created as E001 and it is stored in the model files, the message comes informing about the same, click on OK to close it. The process will appear 21 times for center line strings E001 to E021 and the above actions are to be repeated each time. Step 40, as the whole process is over, next, click on button Draw Ground Long Section, as the list comes, select string E001 and click on OK, to draw the vertical profile of string E001. Step 41, the vertical profile of the rail track center line string M001 is to be designed in respect of vertical profile of the string E001 by following the procedure as described in Chapter 2. The 300 via line data is taken from the vertical design report and is pasted here. The process is to be repeated for all the strings E001 to E021 to design vertical profiles of strings M001 to M021. To process 21 via line design data is the list, click on button Proceed. Step 42, the design of vertical alignment of 21 railway track center lines will be processed, to accommodate the 21 trains in the yard. The batch process window comes with the list of 21 numbers of via line data, click on button Proceed. Step 43, as the process comes, click on button Proceed. Step 44, as the process is over, the message comes informing about the design report, click on OK to close it, click on Finish to quit the process. The process will appear 21 times for center line strings M001 to M021 and the above actions are to be repeated each time. Step 45, click on button Finish to quit the window after all 21 via line data in the list are processed. Step 46, next, click on button Draw Vertical Profile, a list comes with all the strings from M001 to M021, select string M001, click on OK, the vertical alignment of string M001 is drawn. Step 47, click on button Grid On, this will display the grid in scale 1:10 for shenages to elevations. Step 48, the dialog box comes, the default parameters are mentioned and click on OK. Step 49, the grids are displayed with 1:10 scale over the designed vertical profile of the track center line, shenages are displayed at the bottom and elevations are displayed at the left vertical side. Step 50, click on button Vertical Details On, this will display details for vertical intersection points, VIPs, and vertical curves. These actions may be repeated for other strings of M001 to M021. Step 51, the design vertical details are displayed along the vertical profile of the track center line. Step 52, next, open the tab page for Step 6, there are 2 more tab pages under this tab page. The tab page Define Cross Section is currently open for creating the elevations of strings OL01 and OR01, the left and right railway lines for each track, and strings OL02 and OR02 for the embankment edges as offset strings in respect of center line M001. The offset strings are not influenced by cant or super elevations at horizontal curves, because of slow speed of trains. As the gauge of railway track is 1.676 meters, so distances of either side track from center line is 0.838 meters and embankment edge is 1.838 meters, by providing either side shoulders of width 1.0 meter. The cross-section is to be created for all center line strings starting from M001 with offset strings 01L1, 01R1, 01L2, 01R2 to M021 with offset strings 21L1, 21R1, 21L2, 21R2. Click on button View TCS. Step 52, the TCS is opened with Heads Rail CAD Viewer. Use may see the elements and the dimensions in the TCS. After viewing, close the viewer. Step 53, select a reference string. Next, select broad gauge railway track 1.676 meters, and next click on button Assign. Step 54, next, open the tab page Process Cross-Section Data and click on button Process Cross-Section Data. Step 55, the list comes to batch process 21 data files to create the embankment formation. Click on button Proceed. Step 56, the process dialog box comes, click on button Proceed. Step 57, as the process is over, the message comes, click on OK, then click on button Finish. Repeat the process for all 21 data. Step 58, the next process will create the cross-section of the formation at the top, by uniting all the strings from CL01 through CL02 on the left side of the center line and strings from CR01 through CR02 on the right side of the center line, in actual sequence of their occurrences as CL02, CL01, M001, CR01, CR02, in the cross-section. Step 59, the message comes to start the process, click on OK. Step 60, the message comes, click on OK. Step 61, as the process is over, the message comes informing about the output, click on OK and Finish. Repeat the process for all 21 data. Step 62, as the batch processing is over, click on button Finish at the right side below the process list. Step 63, the dialog box comes with list of all strings, click on button Draw Strings. Step 64, the strings are drawn, click on button Create Cross-Section Drawings on the left side of the window. Step 65, the cross-sections are displayed, these are for viewing only. Step 66, select a string for a particular track center line. Step 67, select any shennage to view the cross-section, and the cross-section at that particular shennage will be displayed. Step 68, user has to check the cross-section with the plan view as displayed on the right side of the window. Step 69, open the tab page Step 7 for volume to compute the quantities for earthwork, select a string to compute the earthwork for the particular track. Step 70, the process dialog box comes, click on button Proceed. Step 71, as the process is over, the message comes, click on buttons OK and Finish. Step 72, as the process is over, the result is displayed on right lower panel, and the report is written in file volume.rep, click on button Draw Mass Hall Diagram, the diagram is drawn. Step 73, next, the tab page Step 8 is opened. Under this tab there are 3 more tabs. Currently the tab Plan is open. To create the plan drawing, select a string, say, M001 for the center line of a particular track. Step 74, click on button Add Strings Set for the selected track. All the strings may be selected and added, one by one in the similar way. Step 75, put check mark on Select Strings, and the strings may be selected from the list in the table below. The various data is given, user may change the data as desired. Refer to Heads Rail main screen help to understand the data. Click on button Process Data. The process starts to create one single plan drawing or a set of plan drawings at an user given shennage interval. This is described in the Heads Rail main screen help. Step 76, the dialog box comes, click on button Proceed. Step 77, as the process is over, the message comes, click on OK and Finish. Step 78, next, under the tab page Step 8 the tab profile is opened. To create the drawings for schematic drawings for horizontal alignments, click on button Process Data. Step 79, the process starts to create schematic drawing for the horizontal alignment and the dialog box comes, click on button Proceed. Step 80, as the process is over, the message comes, click on OK and finish. Step 81. The next process starts to create schematic drawing for the vertical alignment and the dialog box comes, click on button Proceed. Step 82. As the process is over the message comes, click on OK and finish. Step 83. As the processes for creating schematic drawings are over, click on button Process Data. Step 84. The process starts and the dialog box comes, click on button Proceed. Step 85. As the process is over the message comes informing about the output, click on OK. Step 86. Next, under the tab page Step 8 the tab page cross-section is opened, TS to create the cross-section drawing, S. Step 87. The default data are mentioned, accepting the same data click on button Process Data. Step 88. The process starts to create a set of cross-section drawings at an user-given Schenage interval and drawing sheet size. This is described in the Heads Rail main screen help. The dialog box comes, click on button Proceed. Step 89. As the process is over the message comes, a set of 5 cross-section drawings are created at an user-given Schenage interval, click on OK and finish. Step 90. Next, the tab page Step 9 is opened. Under this tab there are 6 buttons, click on the button Create/Update Project Data File. Step 91. The project data file is created and the message comes, click on OK. Step 92. Click on the button Open Project Data File. The project data file is displayed on the screen and is also opened in Notepad to take printouts. This the back file of the design data and may be processed along with the total station survey data file by taking these two files in a new folder. Step 93. Click on the button View Survey Data File. The total station survey data file is opened in Notepad to view or to take printouts. Step 94. Click on the button View Report Files. Step 95. The window opens with a list of report files on the left side. Select a report and the report file is displayed to view or to take printouts. Step 96. Click on the button View Drawings. Step 97. The message box comes, click on button Yes. Step 98. The Heads CAD viewer opens with a list of various drawings created inside a folder Design Drawings. Inside the project folder that was created at the start of this session under the working folder select by the user, select a drawing in the list and the drawing is displayed to save or print. After viewing the drawings close the CAD viewer without saving the drawings. In unauthorized version of Heads Rail the drawings cannot be saved or printed. Step 99. By clicking on the button Open Viewer user can open the Heads CAD viewer. Step 100. We are again back to the tab page Step 9 of the project workspace. Close the project workspace. The message comes asking whether to save/update the project data file. Click on button Yes. Step 101. The message comes, click on OK. This is the end of Session 4 Method 1, Workspace Method of Interactive Design 4.4, Railway Yard Design.